looking at notes Y-1, sum and difference formulas, but we will need to do the splitting. In Y-1, the angles were already split for us. So when dealing with sum and difference, you're going to want to use degrees because dealing with radians is going to be much more difficult because dealing with fractions, of course, and finding common denominators, all that stuff takes a lot more time and a lot more effort. So we're going to use degrees. So what I want you to know is that on the unit circle, you have 16 numbers that you have memorized, 16 degree positions on the unit circle that you have memorized, and these are all of them listed. So keep these in mind as you're splitting. So given the angle, split these, you must use all positive numbers. Given the angle 105 degrees, okay, how can you split that? Because 105 degrees isn't one of the angles on the unit circle that we've memorized. How do you split that into angles that we have memorized? Well, you can get 105 degrees from 45, I'll write it over here, is equal to 45 degrees plus 60 degrees. And since 105 is such a small number, this is the only pair that will work. Okay, let's look at number 2, however, negative 165 degrees. The first thing you must do is you must rename using positive coterminal angle. So the angle that lands in the same place but has that positive angle. So think about where negative 165 degrees is. Remember, this is the positive direction of the unit circle while this is the negative. So what I want you to think about is this, if you start here and go this way in the negative direction, this is negative 180. Okay, so 165 would be 15 shy of that right here. So if this were 15 degrees, if the difference between here and here is 15 degrees, this would be your negative 165 because that's negative 180. So let's think about our coterminal angle that's positive, okay, that lands right here. What would that be? So going in the positive direction, again, this is positive 180. So add 15 more to that, and that would be 195. So the positive coterminal angle would be 195 degrees. So split that angle up. So 195 degrees could be rewritten in many different ways. So 195 degrees could be 135 plus 60. Okay, it could be written as 150 degrees plus 45 degrees. Okay, it could be written as 315 degrees minus 120 degrees. Okay, it could be rewritten as, let's think, 225 degrees minus 30 degrees. Could be rewritten as, same thing as 330 degrees minus 135 degrees. And I think last but not least, 240 degrees minus 45 degrees. So notice all these angles here in red are angles that we know from the unit circle. So there's lots of different options for 195 degrees. Okay, let's move on and use given a radian. So the first thing you want to do, like I said at the beginning, is you want to convert to degrees. That's the very first thing you want to do. Okay, so think about where pi over 12 would be. Well, you know pi over 6 is equivalent to 30 degrees, and that's right here. So if this is 30 degrees, you're going to take half of that because that's pi over 6, so pi over 12 would be half of that. So this would be 15 degrees. So 15 degrees is the angle we're looking for. And this one's special. 15 degrees is such a small value. Of course, you're not going to be able to use a sum of two angles to find this angle. You're going to have to use a difference. Here we had a choice. We could use, there were a couple of sums we were able to create, and there's a couple of differences we were able to create. But for 15 degrees, the only thing you're going to be able to use is a difference, because none of these, of course, will sum to 15 because they're all way too large. So here, we could rewrite this as, 15 degrees could be rewritten as 150 degrees minus 135 degrees, because there's 15 in between those two. Okay, I think you're getting the idea, but we will do one more. So number 4, 2 things you have to do. So rename using, I said 2 things, right? Positive degrees. So we want that positive coterminal angle, but specifically in degrees. So again, remember, positive direction, negative direction. Where is negative 13 pi over 12? Well, here, this is negative 12 pi over 12, because this is a full pi, a full negative pi. So that's going to be right here. Remember, we just talked about how each 12th of a pi is 15 degrees. So this angle right here is 15 degrees. So that's where that angle is going to fall. Let's rename it in the positive direction using degrees. So again, if this is positive 180 degrees, this is 15 shy of that. So this is going to be 165 degrees. So then let's think about all the ways we can name 165 degrees. Well, I'm just going to list 2 because we want to move on to the real lesson here. So you can list 165 degrees by taking 120 degrees and adding 45 degrees to it. Or you could even do 30 degrees plus 135 degrees. Okay, so that's splitting. Now let's look at what we're going to be doing with this today. So find the exact values of sine, cosine, and tangent. So again, we're going to have to use our formula card with our sum and difference formulas. So 165 degrees is actually the example we just got done doing. So we split it into 2 ways. We used 120 plus 45, or we used 30 plus 135. Pick one. Either way, you're going to get the same answer, believe it or not. I tried it too. I didn't believe it, and then I tried it, and it actually worked. It was pretty cool. So we're just going to pick 30 degrees plus 135 degrees. But if you also want to try this one, you will see that it works out the same. So we're splitting 165 to 30 plus 135 because we know those coordinates on the unit circle. So let's label them. So think unit circle. We talked in the last lesson where 135 is. We know 30 is going to be right here at pi over 6. So that's A. And then B, 135, remember, is right here. That's B, so let's label. So A is, that is bad news, good news. So square root of 3 over 2, comma 1/2. And then B is going to be negative square root of 2 are twins with a negative x value, a positive y value. Okay, and then also remember, since it wants us to do tangent, let's list those tangent values. So tangent value at A is square root of 3 over 3. Tangent value at B is going to be negative 1. So these are our tangent values. Okay, so let's start with sine. So sine of theta is equal to sine, this is our formula, we're using sum, sine of A cosine B plus cosine A sine B. So sine of 165 degrees is going to equal to this. This is coming from our formula card, okay? So remember, y value of A y value of a 1/2 times the x value of b, negative square root of 2 over 2, plus x value of a times y value of b. Okay, so this is going to give us negative square root of 2 over 4 plus square root of 6 over 4. So, of course, it's going to be negative square root of 2 plus square root of 6 all over that common denominator of 4. Okay, that's sine. Now let's do cosine. So cosine of theta, where theta is our 165. Okay, our formula says, since it's sum, we're not using the difference, we're using the sum formula. It is cosine of A, cosine of B, again getting this off the formula card, minus sine of A, sine of B. So let's go to town. X value of A, so square root of 3 over 2 times x value of B, negative square root of 2 over 2, minus y value of A, 1/2, times y value of B. Okay, so then negative square root of 6 over 4 minus, positive times a positive is a positive, square root of 2 over 4. So this is going to turn into negative square root of 6 minus square root of 2 all over 4. All right, last one, tangent. So tangent of theta equals, from the formula card, tangent A plus tangent B over 1 minus tan A tan B. Okay, so tangent value of A is square, I know it's up there, but you should have it on your paper, square root of 3 over 3, square root of 3 over 3, plus tangent of B is negative 1, plus negative 1, over 1 minus tangent of A, square root of 3 over 3, times tangent of B. So we're going to rewrite, and this is going to look like, let's put the negative 1 in front, negative 1 plus square root of 3 over 3, over, this is going to turn into negative square root of 3 over 3, but it's minus, so minus a negative is going to turn positive. So 1 plus square root of 3 over 3. Okay, and then of course we need to do our complex fraction, so this is negative 3 over 3 plus square root of 3 over 3 over 3 over 3 plus square root of 3 over 3. So we have to have a common denominator to add. So then equals negative 3 plus square root of 3 all over 3 over 3 plus square root of 3 over 3. And then of course, keep it, change it, flip it. So multiply by the reciprocal. So 3 over 3 plus square root of 3, just like before. The 3's simplify, so I'm going to come down right, equals, and drag down. So the negative 3 plus square root of 3 is left on top, over the 3 plus square root of 3 is left on bottom. Of course, you must multiply by that conjugate pair of the denominator. So 3 minus square root of 3, numerator and denominator. FOIL, so negative 9, that's going to be positive 3 square root of 3, another positive 3 square root of 3, so 6 square root of 3 minus 3 all over 9. The O and the I of FOIL will eliminate, and then negative 3 equals, this becomes negative 12 plus 6 square root of 3 over 6. Okay, share the love here. So negative 2 plus square root of 3. All right, so now this is the coolest thing ever. If you want to check your work, of course, sine of theta over cosine of theta is equal to tangent, right? So you could take your sine over your cosine, make sure that that equals your tangent value, and that's to check your work. And that's pretty nifty.